Hey everybody, it's Tony from Adafruit, and this is a stream on using Python with the Raspberry Pi just to do some basic data storage. Like if you're writing a program and you have certain state that you want to store, so like maybe how a user chose to configure the program, something like that, or maybe sensor readings that you've taken from different hardware. How do you actually persist that data and then load it up again and use it? It's something as a beginner that might not be super obvious. Like you could write things to a file and create your own format for that. But I'll show you there are a lot of interesting things just in the standard Python library that you can use to store data, either like your program state or even just time series data like sensor data. And there are lots of other types of data that you can store. So like, a binary file might be one type. You could have all kinds of structured data with relationships, where like a database might be more interesting. And we won't get into those types of data in this stream. I think this is just going to be kind of a little one-part stream series, or this won't be like a long series, where I just wanted to highlight some of these basic ways to store data, targeted more at beginners. If you're familiar with Python, this is probably going to be old hat to you, but still very useful stuff. If you ever wondered, like, I've got my program and now I want it to remember some state, remember how a user chose to do different things, then this will hopefully be pretty helpful for you, that you can get started with this. And who knows, I might turn this into more series or do more videos along with this, because as I started to do this, I realized that there could be a little bit more content here. So, we're just going to do some basic stuff in this stream, and then maybe in a future stream we might come back and do some more advanced stuff for it. So let's just kind of dive in, and we'll get started here, and I'll show you what we've got to demo. So let's switch to the main kind of view here. So as far as the hardware goes, it's going to be pretty boring. I just have a Raspberry Pi 3 just hooked up with network cable. There's really no hardware in this example. It's really just code that I'm looking at in this stream. So don't worry if you need to get anything set up. And you could even do this on your computer. You don't have to do this on a Raspberry Pi, but it's just Python that I'm going to use to do the programming here. And then I've got a connection through SSH to my Raspberry Pi right here. And I also have it set up so that I've got access to the files on the Raspberry Pi in a text editor right here. So we'll go through and edit these. And if you're curious, on the Mac, I'm using a tool called Mac Fusion. It's this kind of neat tool right here where it lets you mount a SSH file system like a Raspberry Pi on your local Macintosh machine. So unfortunately, I haven't seen a tool like this for Windows. There's a tool called CyberDuck that you can use as like a little file browser, but nothing that natively mounts it as like a drive on Windows, which would be kind of nice. That would be a handy thing to add. But anyways, though, so and the code for this, I have all the code that we're going to write. There are like kind of 4 examples here. It's in a gist. And so you're probably not going to be able to see the URL from the video here, but look in the description when this goes up on YouTube, and I'll put a link to this, and so you can see all the code that I'm going to write as we go through this. So yeah, let's just kind of dive in and get started. I'll show you, I have a basic little example here. So if we look at the code, I have the 00_none.py. And also, before I get started too, real quick, I'm going to do everything in Python 3 instead of Python 2. I'm just slowly kind of moving to that. I think it's kind of, the right time to be moving to Python 3. So just as some bootstrapping, because unfortunately they don't include Python 3 by default in the Raspbian operating system. Uh-oh, I just lost a light. Looks like a battery just went out on it. Actually, I might have a spare battery right here. Look at this. We'll swap. Fixing things in real time here. Although if this light went out, then the one next to it is probably going to go out soon, so we'll see what happens. So there we go, that's back. A little bit bright. Let's crank that down. Anyways, though, so we're using Python 3, and I'll show you how to install it real quick. I've shown this a bunch of times, but basically on your Pi, and use the latest version of Raspbian. I'm using Jessie, actually a release that just came out like 2 or 3 days ago. It's the 5.10 release, so they added a few new things, more on the GUI side, but it's always nice to use the latest version. You want to do a sudo apt-get update, of course. Run that. That's going to update all of your package indexes. I'm not going to run it because it takes a little bit of time when I'm streaming here. And then you want to do sudo apt-get install Python 3, and then also install Python 3-pip. It's good to install both of those. That'll give you the Python 3 interpreter and then the Python 3 package manager, because the packages in Python 3 are completely separate from Python 2. So if you need to install libraries, you have to use pip3 instead of the pip command if you're used to that. So just a little gotcha for that. Once you have Python 3 installed, you can run the interpreter. You want to use Python number 3, because that's going to run Python version 3 Whereas if you just run Python, you're still going to get the old 2.7 version. And for this stream, I'm going to show some classes and things that are specific to Python 3. They still exist in Python 2, but they've renamed things. So if you want to do this in Python 2, it's possible, but you just need to figure out like some of the classes I'm using, some of the standard libraries, what they were named in Python 2. But I think going forward, it kind of makes sense. You know, it's Python 3 is really the future, so it's good to stick with that and use that. So okay, so let's look at this example that I have. It's a very simple little example. So I'm just going to run Python 3 00none.py. And it just runs, it's a text mode application here. So it says, hello, no name, your favorite color is black. So it's just picking some default values. And then it has a little menu here, so I can change my name. So I'll say, okay, let's change my name. So my new name is Tony. And let's change my favorite color. So I'll do option 2 and just enter a color. So let's put blue in there. And you can see every time it prints the menu, it says, okay, hello, Tony, your favorite color is blue. So this is state that this program is remembering. Like it knows, here's the name of the user, here's their favorite color. Now I'm going to quit the program, and now I'm going to run it again, and let's see what happens. So you see, now it says, hello, no name, your favorite color is black. So it didn't remember that I said my name was Tony and that my favorite color was blue last time. And that's kind of the big thing that I want to get across in this stream is, okay, how do you write a program that starts to remember stuff like this? You know, I call it state, but it's really just what your program, you know, is configured to do at a certain point in time. And so, you know, there are a lot of ways you could save this data and reload it. And we'll go through a few different options here for it. And first, though, I'll just show you the code for this example. So it's pretty simple and straightforward. It's in the 00none.py. Basically, I create a person class in Python. And in the initializer here, this is kind of the constructor, or it gets called when the object is created. I just set a default name and favorite color. So you can see when it runs and it's printing out no name and my favorite color is black, this is where it's getting that value. So when it loads up, you know, by default, it just sets these to some default value because it doesn't know yet how you've set these values. And then I added a load and a save function, but for now they don't do anything. They just call this pass, which basically is a no-op in Python. It just says there's nothing here. And so we'll see how we can fill in different implementations to save this data in different ways. And then the actual main program, this is where we kind of do the loop to print the menu. So you can see when it starts up, it creates a person object. It calls that load function, which doesn't do anything right now, but we're just going to use this as a base for our other programs going forward. And then I just do an infinite loop here. And every time the loop starts, I print out, you know, hello, here's your name, and your favorite color is, here's your favorite color. So that's just using the format command in Python. So you can pass in these little format strings and give it different variables. So it's printing out, you know, here's the person.name, which is going to get this name attribute that was set up above. And the same thing for favorite color. So it just prints both those out. Prints out the options, you know, 1, 2, 3, change your name, change your favorite color, or quit. And then it does the input command. So this basically waits for text input from the user, and it prints out a little prompt so you can see like, okay, enter which option you want here for that. And a little Python 2 note, in Python 2 this is actually called raw underscore input. In Python 3 they simplified it to just be input, so a little gotcha if you're going back to Python 2. And then I just do a quick little sanity check. I want to see, did the option that they passed in, so like after this input command returns, it gives you back the value that the user entered. So like I entered 3 in this loop. And so after it returns, I just do a quick little check to see, did the user give me either 1, 2, or 3? And it comes back as a string value, so you just want to be careful to check against those. And that one little nice thing I like about Python, if you want to check if a value is inside of some range of values, just use the in operator. You know, it's very readable. You have to pass it a list of things, so I'm passing it a tuple with 3 values inside of here. And so this will be true if option is 1, 2, or 3, which means because I'm using this not, then that turns into false, so it's not going to go into this little check here. But basically this check is looking to see, did you give me any value that's not 1, 2, or 3? And if you gave me one of those, then it's going to print out and say, hey, unknown option. So I'll show you how that works. You know, if I run this example and I say like foo in here, it says, oh, unknown option, and then it just prints out the menu again. And so the way that works is, you know, I print out unknown option, and then I call continue. And so continue will go to the previous loop here, and it basically breaks out and says, okay, don't do any of the code below here. Just stop and go straight back to the top of this loop again. And I think that makes sense because, you entered something wrong. So we say, hey, you entered something I don't know. It's an unknown option. And then we'll just give you the menu again so you can enter an option again and keep going with it. And then after that, basically, if the code gets down to this line here, then it must be a good input. It must be one of these 1, 2, or 3 values. And so then I just have some if checks here to say, okay, if it's option 1, then they want to set their name. And so just use that input command again to ask them for a name value and save it directly to the person.name attribute. So remember, that's on the person object that we created up above. And then same thing for option 2 when you want to change your favorite color. And then option 3 when you want to quit, I basically just say, hey, goodbye, and I call break. And so break will just say, okay, whatever loop I'm inside, which is this big while true loop, it just stops executing that loop. So it breaks out of that loop at this point. And then, so that kind of means that the code will then continue down to this line here, so the next line after the loop. And at this point, I just call person.save, which again doesn't do anything, but we'll see we can fill in code. So this gives me a little good point to say, okay, the person chose to quit the program, and so I'm going to break out of the loop and call the save function here. I could call it inside of here, I could say person.save, but I kind of thought it made more sense to put it outside the loop so that if something else inside of my loop causes me to exit, and I want to make sure that I try to save that person's data. There are different ways you could do this though. Like you could use this thing called a context manager that lets you guarantee that some cleanup code would be called, but I didn't want to make it that complex. If something goes wrong, like if you hit Control-C to quit the program, then it's not going to save your state, and maybe you intended it to be like that. Like you maybe just wanted to immediately exit it, just don't do anything. But that's it. So this loop, actually, I'm not going to change anything in this code for the rest of this video. So it's really just the load and the save functions here that I'm going to fill in, and we'll see a couple different ways that we can save this state. So the basic idea, like you saw, is I've got this program. It tries to load up and see what your name was and your favorite color and print that out, and then you can change that, and then hopefully you can save that so that when you run it again, it'll show you the current value for that. So right now it doesn't do anything. So let's kind of see a couple different ways to do this. And so I'll show you all things that are in the Python standard library. And if you haven't really looked at it, I'll put a link to this page right here. So this is just the official Python documentation. And this is basically everything in the standard library for Python. Great page to just skim through to get an idea. I guarantee you'll find something where like, Python can do that. I never knew there was a library for that. And it's one of the big things about Python. You might hear it described as batteries included, where there's usually a great standard library for almost anything that you want to do as far as like dealing with files and text and data and network stuff. It might not be like the most advanced and the most performant thing, but there's probably an easy way to read and deal with data already in Python. And that's really strong because it means like if I want to write a program, I just need to have Python installed. And if I use a standard library thing, then it's good to go. I don't need to install other libraries, which adds all kinds of complexity. Now you've got dependencies on libraries, and those might have different versions, and they might have conflicts. And so the more stuff you can do with the standard library, the better. And now one really nice part of the standard library is this data persistence kind of section where they talk about how to save data, which, hey, that's exactly what we want to talk about in this stream here. And so they talk about a few different high-level modules that you can use in here. So one is this pickle module, which lets you serialize an object in Python, which serialize means you want to save it as some kind of like string of bytes or data. So you want to convert a Python object into some string of data that you can save into a file. And then you also want to be able to go the other way, where you've got a file that has some string of data that represents a Python object, and you want to come back and create that Python object. So that's a really handy module inside of the Python standard library. So I'll show you how we can use the pickle module to save our state. Another thing I'm going to show too is how we can use this module down here under file formats, this config parser module. So this is a really nice module that lets you create an INI file, like a .ini. If you remember from like the old Windows days, I think Windows 3.1 or so is when they started to really use the INI files. Real simple text-based configuration format good for storing like a dictionary kind of type data structure. I'll show you how we can use this module, and we'll kind of talk about like why you might want to use pickle versus config parser. What are some disadvantages, advantages of each of those. And then the last thing is I'll show you a third example, which isn't based on this kind of name and favorite color. It's more for storing time series data. So for example, if you have a bunch of sensor readings, like you're measuring temperature, humidity, things like that, maybe every hour you want to save that sensor data. So that's a slightly different type of data. It's not your program state. It's not like the name or the favorite color that a user chose. It's a bunch of sensor readings. And they all have time associated with them. This reading occurred at some point in time. And so I'll show you, you can actually use a file format called the CSV, or the comma separated value format, to store this type of time series data. And we'll talk a little bit about what's the difference between just program state versus time series data, and why you might want to use one versus the other. And I'll show you some cool stuff you can do with CSV data. Like you can make a little chart very easily just using some spreadsheet stuff. So let's dive in. Let's look at this pickle module. So if you look at pickle, unfortunately the official docs are kind of complex. So there is a lot of complexity to the pickle module, mostly because it can store almost any Python object. And so Python objects can be pretty complex. And so it has to create all these conventions and patterns for how it turns a Python object into something that can be saved to a file and restored back again. And so there's a lot of little subtle complexity there. One thing that I kind of recommend, and if you haven't really seen it much before, there's a great website called PyMOTW, Pi Module of the Week. And I think it was by a guy named Doug Hellman who created this. I guess it's a blog maybe, but it's more of like a series of articles where every week he would go through a different module in the Python standard library and give you a basic how-to of like, here's what this module does. You can see, so here's the documentation for pickle. And by the way, I'll put this down in the links in the description below. I'll link to this page so you can look at it. But it gives you a little bit easier intro, I think, that kind of describes like, here's what pickle does. It describes a little bit, so with pickle module, in Python 2, there are actually two different pickle modules. There's pickle and there's cpickle. I won't get into many of the differences. Basically, cpickle is a faster version. In Python 3, I think they simplified it and just used that faster version as a default, so you don't even have to care about that. But it just kind of shows you, it will encode a Python object as a string of data, and then you can save that into a file. You can read a file and restore that object back from it. So very handy because, it's just, you've got a Python object, you want to save it, which is exactly what I have in our example here. I've got a person object that has a name and a favorite color, and I want to save this to a file. So let's copy our file and let's make a new version of this. So we'll copy our none file and we'll make a pickle.py file here. And let's look at that file in our text editor now. Let me just refresh this so we see it. There we go. So let's start filling in some of the details here. So to use the pickle module, you first need to import it. So we'll import pickle. And then really at a super high level, to just save an object or to restore an object, there are two functions that we care about in this module. So there's a load and a dump function. And you can see here, so the dump function, basically you give it a Python object and a file, and it's going to write a text representation of that object to that file. And that representation can be later reloaded using the load function, where basically you give it a file and it's going to return back a Python object that it parsed from the text in that file. And so they both kind of go hand in hand. Like whatever file you save with pickle.dump, you can reload with pickle.load and you'll get back a Python object. And I should kind of say that, that's how it works at a high level and how you're supposed to think about it. But there is more complexity, and you do want to kind of skim the documentation and definitely read this PyMOTW article on it, because there are certain objects that can't be pickled. You can get into these complex states where, like, if a class references another class and then maybe there's like circular dependencies here, you can get into weird states where it can't figure out what you're trying to do. But for simple things like this class we have here, where I just have a class, it just has some basic attributes. These are just text values. This is perfect. Like these could be numbers, these could be anything. It's as long as it's a simple class with state that's all easy to represent in Python. And if you do have an object that's more complex, it has hooks where you can plug in functions that tell here's how to serialize this class into a string. But we're not going to get into that. That's pretty advanced usage of this. We just want to keep it simple. So, our class basically is as close to our data as possible. Like it just has that name and favorite color. So, okay, and like I said before, like I don't need to change anything in my main loop here, or my main function. I just need to fill in this load and save function now to use this. So, okay, so I imported the pickle module. So let's do the maybe the load function first. So I'm going to use the pickle.load function, like I mentioned. So I need to give it a file. So first of all, I need to open a file, and the great convention in Python, you want to use this context manager with the with command. So you say with open, and we'll give it a file name. So I'm just going to pick a default file name. I'm going to say my person.pickle, and then I need to tell it to read that file. And you also want to tell it to read it as a binary file. I'm pretty sure we want to say read it as binary. We'll just quickly check the example here. If you scroll all the way down, which another thing I don't like about this this documentation here is like you have to go all the way down to the bottom to just get a basic example. To put this up at the top, that would be a lot easier for people here. So okay, yeah. So you do want to read with the B option, which says I'm reading a binary file. It always kind of tripped me up, but something I don't like about Python, it's nice. It has a distinction between reading a text file versus a binary file. And from what I understand, this just changes how it interprets line endings. So if I'm just doing the R, this says read a text file. And if I iterate through this line by line, it's going to look for platform specific lines. Like on Windows, I think a line ending is just a /n new line character, versus on like Linux and other file systems, it's /r/n, a carriage return and a new line. So this tries to hide those differences, versus if you use the B option, the binary option, it doesn't do any of that process. You just get the raw bytes of this, and if it only breaks new lines on the /n like new line character. It's a subtle distinction. It confused me a lot when early on learning Python. In most cases, you probably want to deal with binary files. But sometimes if you're reading lines of text and you're doing it cross-platform, then you might want to use just the R option for this. So okay, so we open this file for reading, and then the context manager gives you an object back. So we'll just say this is my pickle file object. And now inside of this context manager, I can operate on this pickle file object. And then as soon as my code exits, for any reason, like if there's an error, if I press Control-C to stop the program, it's going to make sure that this file is closed. So that's the nice or the good reason to use this with context manager, is that it makes sure your file is closed. You don't have to manually call the close function on this, which in most cases it's not too bad to open a file and never close it, because when your program exits, the operating system is going to clean up that file handle. But it's smart to get into the practice of when you're dealing with resources like this, be very explicit about opening and closing them, so that later on when your program gets more complex, you don't run into subtle bugs because you opened it and you never closed it, and then you try to open it again and all kinds of things are messed up. So anyways, so now that this is open, I can call the pickle.load function, and I can send it a file. So I just send it the pickle file, and it's going to return back an object. So I'm going to say we'll assign that to a person object here. And then what I can do is I can just pull out the different attributes. So it's actually going to construct a person object, and it's going to load whatever name and favorite color attributes were saved inside of there. So I'm just going to copy those out into the current class. So basically the self values here. So self.name equals person.name, and self.favoriteColor equals person.favoriteColor. So I'm just copying these values out. It might seem a little weird in that, like, well, couldn't I just load the class itself? And I could do that, but it's a little trickier when I'm doing it in a function inside of the class. So I think it's simpler to just load a copy and then copy out the data that I care about from it here. And then let's see, I don't need to use this pass. Now, the one thing I do want to be careful about, because I want to kind of preserve the behavior that if I've never saved this data before, it's going to pick those defaults. So remember, it has that no name and favorite color of black as the default here. So you kind of have to think about, okay, what happens when load is called? It says load person.pickle, but if I look at my files, like right now, I don't have a person.pickle file. So this open command is actually going to fail. It's going to throw an error. It's going to throw a file not found error. And basically what I'm thinking is, let's just catch that error and do nothing. So we'll just ignore it. Like we're just going to say, okay, you tried to load the file didn't exist, so don't do anything and just move on. And it's going to keep the default values that we had before, because this code didn't run to overwrite them with other values. So to do that, I just want to put everything inside of a try except block here. So we'll say try, and then we'll say except file not found error. And I think that's the error type. We'll see if I got this right or wrong when I run this. But basically, if I catch this error type, then I'm just going to do nothing. We'll just say pass. So it's just going to, it's going to make an attempt to open this file. If it can open it, it's going to use the pickle class to load our object from it, and then it's going to copy out the attributes it cares about. If it couldn't open that file, then it's just going to swallow that error effectively and just say, oh, I made an attempt, but I couldn't find the file. And so it'll stick with the defaults that we had before above here. So that's how we load it. And now let's see, to save it, it's actually pretty simple. So in this case, I'm going to do a similar kind of file open command here. So I'm going to do with open, and we're going to do the same file name, person.pickle. And this time I'm going to open it for writing a binary file, the WB option. And the way I'm calling it like this, WB, it's going to overwrite whatever was in the file. It's just going to completely erase the old contents of it, open it up fresh and new, and so I can stick a new set of values inside of there. So we'll do the same kind of convention here. We'll say pickle file is my file. And then to save this, it's really easy. You just call pickle.dump, and you give it an object. So I actually want to use self, which is saying save this current object, this current person instance. So it's going to save all the attributes associated with it, like the name and favorite color. And then I need to give it the file to save to. So we'll say the pickle file inside of here. And that's all I really need to do. So this is going to dump the data to it. And then as soon as it gets to the end here, this with context manager is going to close that open file, and we should be all good. It should save that file. So let's save this and let's run it, and let's see what happens. So we'll do Python 301, the pickle.py file. And okay, so I got the error wrong there. So basically it exploded, said, oh, file not found is not defined. So let's just check real quick. The other thing I love about Python, you can just open the interpreter. So if I just call open foo.text, let's see what error it returns. So it's file not found error. So that's basically what I want to look for as the exception type. So okay, easy fix for that. So I'll say file not found error. Oh, hey, look, it highlights that my text editor happens to know that that's a standard exception. Okay, so let's run that file again. So okay, so you can see I ran it, and look, it picked the defaults. Like it couldn't read a pickle.py file, so it used the defaults. And basically what happened here is we created the person object. That's going to set it up with the default values of no name and favorite color of black. We called the load function, so that's going to run this code. It tried to open that person.pickle file, but it just failed with an error. And we don't see anything. Maybe I should have put a print statement in here that said couldn't find the file. But it basically threw that file not found error. And so it didn't do anything. And so it just left these with their default values, the favorite color and the name. So let's change these. We'll say name, we'll say Tony D. And then favorite color, let's set this to, how about electric blue? Okay, so now we see, so it knows, hey, Tony D, your favorite color is electric blue. Now let's quit, so I'll say quit. And now let's run it again. Let's see what happens. So I'm going to run this, and look at this. Hello, Tony D, your favorite color is electric blue. So that's pretty cool. It remembered that state here, and I can change it. So let's change my favorite color. Let's say, how about pink? We'll say pink is the favorite color. So I've got the same name, but now a new favorite color. Let's quit the program. Now let's run it again. And we see, look at that. Hey, Tony D, your favorite color is pink. So pretty cool, pretty simple and easy. I mean, it's really just like one line to save and load a Python object to a file. Now, an interesting thing, let's look at that file and see what it looks like. So if I refresh the files on here, you can actually see here's that person.pickle object. And so you can see this is maybe not the best thing for a human to look at. So there's like some bytes in here. You can see some text, like here's person, here's name, and here's like the Tony D value, and here's favorite color. You can see pink. So like I can see that the values are inside of here, but this is definitely not a format where I'm meant to read it. You know, like a human, like if this was a configuration for my program, I couldn't tell people like, oh, if you want to change your name, go in and find this line with this crazy X name X. You know, it's not the intent that people are supposed to read this file. Basically, the pickle module is really just made for Python code to save and restore an object entirely itself. Like it won't give you, you know, an easy way to deal with that data yourself. It does everything automatically, and so that's it's an advantage in that like it's very general, so it can deal with, you know, any Python object. I can add more attributes to this. You know, if I wanted to have maybe my self.favorite food, you know, I can just throw something in here, like here's a default value, and it would save that value and it would restore it. And, you know, I don't have to mess with a bunch of extra code here. Like, you know, maybe I need to copy out that extra value inside of here. But it's, you know, as far as the pickle.load function is concerned, this class could have as many attributes as it wants, and it's going to save them all. And the same thing for, you know, the dump function. It's going to read all those back out. It's going to save them all with the dump and read them all with the load function here. So it's nice that it's general, but maybe not the easiest file format to read yourself, because there are instances where you might want to be able to edit that configuration with a text editor. Like if this is a configuration for how your program should run, you know, you probably want to tell people like, okay, edit the configuration file with the text editor, change, you know, these values to modify how it works. If you didn't do that, you'd have to like have a whole different program that people would run that would let them edit the config file and save it to the file, which is kind of painful. You know, it's nice to give people more options. And it's also nice that if it's a text file, other programs could read that file and modify it. So with this pickle class and module, it's really only Python code that can read it. And you do even need to be careful, because I think like older versions of Python, you know, if the pickle format changes, it might not load in that version of Python. So you could be kind of locked into the version that you're using. You know, it's very, very specific to the Python code that's running. Whereas if I could save this data into a standard text format, then I could write a program in any other language that can read text files. So like I could write it in Node.js, I could write it in C or C++. You know, if it's text, all of these different languages have ways to operate on those kind of files. And so that's a great way where like, you know, maybe I just define all my state in some text file and then other people write their own programs that can modify it. You know, it's a perfectly valid and maybe a desired way to write a program. So let's see how we can change our program example here to use an INI style format of a configuration file. And so like I mentioned before, we'll use a different standard library. So this is the config parser standard library in Python. And just a note also, in Python 2, they changed the name of this. Or in Python 2, it was called config parser with uppercase C, uppercase P. In Python 3, they just renamed it to be all lowercase to be consistent with everything else. So just a word to the wise, if you're going to use Python 2, you might need to change the name of some of these things. But basically, the config parser, the docs on this are a little bit easier. I like they have a little quick start here that shows you the basics of using it. So this is what an INI style configuration file looks like. It's a text file, and it's really similar to a dictionary. So like you can have a section which just defines a bunch of values that are associated with, you know, that section. So like a default section. And then inside of there, each line is just a name value pair. So like you can say, okay, the server alive interval equals 45, and then compression equals yes. You know, these are just different values associated with these names. So you might imagine like a Python dictionary object that has a server alive interval value inside of it, you know, that's set to 45, and same thing for compression and all these things. So it's very simple text format, you know, not complex, definitely human readable. You know, you might compare this to other text formats that you might have seen or heard about, like XML is a real popular one, where it's, you know, the extensible markup language, where you kind of encode things inside of brackets that describe the data. And that one can be a little tricky. Like there was a time, you know, maybe 10, 15 years ago where XML was everything. And I think we've kind of learned since then that, you know, when like XML is great for storing program data, kind of like the pickle module. But it's not the most friendly thing for a human to edit, you know, because you have to, the format requires like opening and closing brackets of things, and you know, you can mess things up pretty easily, not be able to parse the file. So I like to keep things simple, and I really do like the INI style of file format because it's text, it's easy to describe it. You know, even a non-programmer can look at this and know, okay, like if I want to change configuration, this isn't some scary stuff that I need to do. I can just go in and edit this file. And luckily, this config parser module is really excellent in Python. Makes it super easy to read and write these config style, INI style config files. And so it just kind of shows you right here, this is an example of writing a file. You create a config parser object, and then it just looks and feels like a dictionary in Python. And this is, again, another difference between Python 2 and 3. In the older Python 2 version of config parser, it has a totally separate style for how you interact with the data. And I think Python 3 actually has that old style, but you have to call like these explicit get and set functions on it. Whereas in Python 3, I really like what they've done. Like, it just looks and feels like a dictionary. So they're showing in this example, if I want to, you know, set this default section here, you just operate on it like it's a dictionary. So you say, okay, I want to pick the default section. You know, I use the bracket kind of syntax here, and then I can just assign a Python dictionary to it. So this is assigning the dictionary with, you know, your server alive interval, your compression level to it. And then it's also going in, and here's another section inside of here, and it creates it as an empty dictionary. And then you can see you can actually reference an object inside of this section, just again using that dictionary kind of syntax for it. So super easy. I mean, this makes a lot of sense to me. Almost feels like, you know, your code is very similar to what the config file looks like. And then to actually write it out and save it, super easy. You just call the write function on it and you give it a file. So let's do that. Let's use this. And to read it, they kind of show also it's very, very similar. You call this read function. This you can actually point at a file and it'll open it and read it in. Or you can even, there's a read underscore file function where if you've already opened a file, you can give it that. And then once you get it back, you can operate on it just like a dictionary. So, you know, if you know that there's a section in there called default, you can pull it out with this kind of syntax. And if you know there's like a compression object inside of there, you can pull it out and grab its value from that. So let's use this module. I think this will be an interesting way to change our program. So let's just quit out of this example. So let's copy our pickle example, and we'll call this config parser.py. And then let's load this up. So let's just refresh this. Okay, so config parser. Okay, so let's go in, and now we need to import the config parser module. So we'll change that. And okay, let's go again with our load function. So actually this is, now it's implemented, so we'll remove that comment. So okay, so for our load function, it's kind of similar convention I think we're gonna follow. So let's open a pickle.ini file. And this time we can actually just open it as a text file. You don't need to explicitly say to read it as a binary file. And let's call this our config file. And now, so when we're loading, I want to be able to read the file and then pull out those attributes that I care about that I've stored inside of it. So we're going to do pretty similar code. So first I need to create a config parser object. So we'll say config parser.config parser. Then I need to tell it to read the contents of a file. So we'll say read file, and I give it that config file object that was created right here. And so it's going to read, it's going to parse that file, load it all up, and then at this point my config object is basically a dictionary where at a top level every section has a different name you can index into. So like let's say I have a top level person node inside of here, and then another level below that, so each of the different values inside of there, so like you saw here, you know, here's your section name, and then here are all the values inside of here. I can pull out individual values just again by referencing them like a dictionary. So let's say I have a name attribute inside of there. And so I can actually just say, let's assign, you know, my person name value to this object's name, and exact same thing for favorite color. So we can just say, let's grab the config, your person, and your favorite color. So let's put this in, and we'll just change the name of the attribute I'm looking for to, not favorite name, how about favorite color inside of there. So, okay, that's pretty easy. I mean, basically, you just read the file, and then at this point, your config object looks and feels like a Python dictionary. If you wanted to test, like, is there a person section inside of here, you could say, like, is person in your config object, and then, print out found a person. And maybe if that's not true, you could throw an error or do something like that. So, very handy, easy little syntax in Python. So, okay, so let's save that. And again, I'm going to do the same behavior where if this open fails with a file not found, just pass, just continue, don't do anything. So let it use the default values here so that you can kind of bootstrap this. You can run it without having this configuration file, and it's going to save the default values. Now to save this object, it's pretty similar to the code we had before. So now I need to change the file name. I'm going to say person.ini, and I'm just going to write it as a text file, so I don't need to write it as a binary file. And again, we'll call this my config file. And then here, now I need to change things. So again, I have to create a config parser object. So we'll say config equals config parser dot config parser. And then here, I can assign values to my config parser object. And so, it's a dictionary. So I can say, hey, I want my person section to equal, and here you can actually give it a dictionary. So I could give it an empty dictionary and then use syntax like this to say, here's my person and the favorite name, or the name of them, we'll say equals self.name. I could do this, or a little bit simpler syntax, because I'm giving it a dictionary, I can just put all these values inside of my dictionary. So we'll say name equals self.name, and favorite color equals my self.favorite color. So, okay, that's pretty easy. So, okay, we'll save that. And then there's one more little thing I need to do, the very important step. I need to actually write this out to a file. So I want to say write to the file that we've already opened, the config file there. So, okay, so we'll save that. And let's just double check that I've got the syntax correct for writing it. Yeah, it's basically right. You give it the file there. So, okay, cool. So let's save that. I mean, you can see it's really similar to the pickle module. I mean, the same basic idea. Like, I'm loading my state from some file. With the pickle module, it gave me back a Python object, and I could just pull out those name and favorite color attributes of it. Whereas with the config file, it's not as smart. It doesn't know natively how to turn a Python object into a config file kind of type structure. So I manually need to do that. So I need to say, like, okay, grab the name from inside the person section and grab the favorite color from inside the person section and save those as my values inside of here. So, it's different. It's not as extensible in the sense that I can't just slap on new attributes and they're just automatically going to be saved. Like, I have to actually add some code so that when I save them, I explicitly call it out. But I think that's kind of a nice thing in that it lets you kind of separate, what is your core program state from all the objects and things that you deal with in the program itself. And so, if you can just figure out, like, it's really just name and favorite color that define the state of this program, then I can store those any way I choose. I'm not tied into how, like, the pickle module might represent it. And so I can choose to serialize them as an INI style config file here if I want. Or maybe in the future, if INI style config files go out of favor, there's some brand new cool format that everyone wants to use. It's easy to change that over because that it's just these 2 bits of state that I need to save for this. So, okay, so let's save this and let's try it out. Let's see what happens. So let's run Python 3 and the O2 example, our config parser.py. So again, you can see it starts up, we get no name, favorite color is black, so we're getting our defaults, everything looks like it's working. Basically we tried to open the file, it failed, and so it just did nothing and we got our default values. So let's change our name, let's say Tony D, or how about this, we'll say Adabot. And then let's change our favorite color, we'll say maybe his favorite color is silver. And so again, you can see, so my program remembers these values, and then if I say quit, we exit, and now I run the program again, and hey, hello Adabot, your favorite color is silver. So that's pretty cool. It's working, it's saving and restoring our values like we thought. Now the cool thing is, if I refresh the files, we can look and see, here's my person.ini file. And look at that, it is a simple text file, human readable, very simple and easy to understand this file. And I can actually change this in my text editor. So like, let's say, Tony D, we'll save that. And now when I run the program again, we can see, hey, hello Tony D. your favorite color is silver. So it's just reading these values directly from this config file. And I like this a lot because, by putting my state into a text file like this, it's easy so that in the future, if I want to change how this program behaves, I can just go in with a text editor. I don't need to worry, like, am I getting the syntax correct for this? Or I don't need to write a program to edit my configuration and save it in some custom format. It's much simpler and easier to use. So, I like this style for saving state of your configuration of your program. I think it's something where as long as your program is simple and you don't have like really complex objects, or even if you do have complex objects, break it down into like, what is the core state that I need to save? Just the strings, the text, the numbers, and you can save any kind of object inside of these config parser values. This could be a number, this could be like 102.2 or something like that. You could put anything inside of here that's like a basic kind of data type, and you can load it back up and use it. So it's it's simple, human readable, but easy though. So you can see in the code it's not much different than using the pickle module. It's just you kind of have to change how you open the file and deal with it as a dictionary object for this. So that's pretty cool. Those are a couple ways to store your program state. There are lots of other ways to do it. So if I go back to the Python standard module, you could use like the SQLite module. This one uses the SQLite database, and I think I might do a separate stream, maybe a multi-part stream on using SQL and SQLite in particular, because a database is a great way to store state of your program, to say, here's my configuration, maybe here's a bunch of data that represents all the things inside of my program, maybe how all these different modules and things should be configured. So database is a great way to do that, because a database is basically a file that can represent data and the relationships between data. So you can say, I have a person object and it has a name and a favorite color, and then maybe there's a family object which is defined as a bunch of people that are associated with each other. And so databases have great ways to say, here is a concept of a person and a family that contains a bunch of people. And so there are lots of powerful things you can do. There's a whole kind of language for how you query a database. And the databases themselves can be implemented in such a way that they can be really efficient about like looking up, if I want to find all the members of a certain family, they can index data in lots of ways. But it's a very complex and kind of broad topic, so I'm not going to get into it in this video, but it's a great thing to think about, and maybe a follow-up video will look more at how to use databases, because again, Python makes it super easy. It's built into the standard library. You're ready to go with databases. So that's one way to do it. There are other formats though. The JSON format is a really popular one these days. So JSON format data, it's again a standard module in Python. There's the JSON module, very similar to the pickle module, where it has a load and a dump function. But this time it basically saves a Python dictionary or array object, like a list object. You can serialize any of those, and as long as your dictionary has basic Python data types or types that can be converted to strings, it can save that as a JSON format, which is like the JavaScript object notation. And so they might have some examples here. You can kind of see, it has like, this is a JSON object that has an attribute named JSON. So it's, maybe they don't have good examples in here, but it's another file format. You could use it, there's certainly no problem using JSON. And again, it's a text format, so you could go in with a text editor and edit it yourself. I don't like JSON as a config format though, because it's a little verbose, and it's a little weird. It's prickly with the syntax. You have to get, your curly braces lined up and commas in the right spot and stuff like that. So, for a format that like your program's going to read and write, that's great. And especially if your program deals with JavaScript code, like if you have a web app that's maybe sending some state down to a client web page, JSON is super easy for JavaScript to read. But if it's me as a user, I don't think it's as nice as this config file, this INI style format. This is much easier to read and deal with. So, those are just a couple different options. You can look around too. There's plenty of other options in the standard library, but I think those two are the most interesting for storing program state. Pickle, which kind of lets you deal with just, I've got a Python object, I want to save it to a file and load it from a file. And then the config parser, which says, okay, I want to read and write INI style files for this. So the last thing that I wanted to do was just give an example of another type of data. So I mentioned time series data. So this is data where you might think of like a list of sensor measurements. Like if I had a humidity and a temperature sensor, and every second I wanted to take a sensor reading. And so how could you store that data? You know, you can't really map that to an INI file. I mean, maybe you could, where like you have a section for each point in time, and in that section you have like a humidity and a temperature, but it gets kind of clunky and verbose and a little weird. You could make your own file format, you know, open a text file, and maybe each row you put in some different values here. But there's already a format that works really well for this time series data. So it's the comma separated value, or the CSV file format. And so this is basically just like the name says, you have data, each line has a different row of data, and inside of that data, you can put a comma in between different values. So, you know, if I want to save temperature and humidity, I could just say on each line have temperature, comma, humidity as my two values. And I mentioned time series. This works really well with time series data, because if I just stick a timestamp on the front there, so like, you know, the time that that sensor reading was taken, then again, that can just be another attribute that's in my CSV file. And when I want to read that back later, I can process it and know, okay, you know, at this point in time, here's what the temperature and humidity looked like. And it's all on one row, and it's all really easy to read and write it. And it's super easy in Python. They have this great little CSV class that basically has a reader and a writer function you can call that give you back a reader and a writer object that lets you read and write CSV data. So I was thinking we'll just do a really quick example here of writing sensor data to a CSV file, and then I'll show you something cool, how you can use a spreadsheet to open that up and build a graph out of it really easily. I think I've shown this before, but I'll show it again because it's really quick and simple. So, you know, this is basic idea of like, you've got some script, you're taking sensor measurements, you want to throw them somewhere that you can read them later and remember, you know, look at that whole history of how did my temperature change over time, or how did my humidity change over time. So let's make a new file here. We'll quit out of here, and let's just, let's see, we'll say touch 03 time series csv.py. So that creates an empty file, and then let's open that file up in our text editor here. So, okay, so to use the CSV class, it's pretty simple, and they give you a quick little example here. So here's how to read. We're just going to write in this example, so we'll look at the writer example. But basically, you know, again, you open the file yourself. So this opens this eggs.csv. Then you create a csv.writer object, and you give it that file that you've opened. And there's all kinds of extra parameters here. You can change, like if you don't want it to be comma separated, if you want it to be like tab separated, you can change these delimiters and all kinds of little knobs you can tweak on it. But I'm just going to pick the defaults. Like, you know, we don't need to make this super complex. And really, you just call write row, and you give it an iterable thing like a list. So you say, you know, here are all the values I want to write in this row. And this class will take care of writing that to the file, putting a comma in between them. And you might kind of wonder, especially if you've used Python to read and write files, like, couldn't I just do that myself? Couldn't I just take my values and write out a string that is, you know, value 1, comma, value 2? And yes, you could do that. You know, it's perfectly valid to do that. But there are some very subtle things with the CSV format, because, like, imagine, you know, what if my name that I put in here was Tony, comma, D or something like that, so that, you know, the name that I want to store as a CSV value, for example, has a comma inside of it. That's going to screw up your file, because when you read it back, you're going to see, okay, I get Tony, comma, D, which is really one value, but my code doesn't know that that's, you know, as far as it's concerned, it sees a comma and it knows, oh, that's the separator between those two values. And there actually is in the CSV format a way to escape commas. I think you put the entire line in double quotes, if I remember correctly. And then that says, or you don't put the entire line, you put your value inside of double quotes. And that kind of tells the CSV interpreter, okay, ignore any commas I have inside of my value. So I mentioned this because it's complex logic, and you're probably not going to implement that logic when you do your own CSV reading and writing by hand. And it's super easy, you know, you fall into that trap of like, I'm just going to do it myself. And then suddenly later on, you know, 6 months down the road, somehow I get a comma in my data and my program explodes in some way that I didn't realize, it's probably going to be a subtle way, because the file is going to be read, but you're going to get only like half of the values that you, or half of the data that you expected inside of there. So it's, the smart thing is to use this CSV class, because it will take care of that for you. It will look at the data that you're writing, and if it has a comma inside of there, it's smart enough to know, oh, I need to escape this. And well, what if your data has like what looks like an escape character inside of there? Then it knows how to escape that. So it does all that junk for you, and it makes it really easy. Like, you just call write row, give it a list of things, and it's going to write out your data for you. So let's do that. And we're just going to do toy example. Like I mentioned, I don't have any hardware here to demo it with. We're just going to make up some random values basically and just save those to a file. So let's just kind of get started here. First, I need to import the CSV module, and then I'm also going to import the random module, the time module, because I know I'm going to need to delay for a second. Basically, in this program, I'm just going to have it generate random sensor readings every second and write them to a CSV file. And then I'm also, because I've done this before, I know that I need to import date time to get a nice, easily printable date time value for this. So, okay, so in my main loop, I'm just going to dive right into the loop for it. It's just going to run forever. Basically, we'll say, well, there's a little bit of setup that I need to do first. So I want to create a CSV object, a CSV file, this writer object that they have here. So we can just grab their code here and we'll use this as a base to start with. So again, you can see, they're using that with the context manager, opening the file. Let's call this sensor.csv, and we're going to open it for writing. They're putting this new line equals blank. I think that means that it, don't add any new lines, or, when I write lines, don't have some special character there. I'm just going to pick the defaults. I want to keep things simple here. So this is going to open it as CSV file, and then they're creating the spam writer. Let's just call this my, how about sensor writer equals. So I'm going to create a csv.writer object, and so that's what this thing is here. And it takes in the CSV file that we opened above here, and then they give all these crazy options for it. Let's just pick the defaults, stick with the defaults unless we know we need something else in the future. So this is just, it's going to use a comma to separate our values. There's not going to be some custom delimiter inside of here. So, and then after this, it's just writing rows. So, I'm just going to erase these and we'll just write our own rows. So I'm going to start with, though, I'm going to write one row that I'm going to call it the header row, where I'm just going to say the name of each of the columns inside of my data that follows. So you need to pass the write row function, rather, a list. And this could be, a Python list object. I think it could be a tuple. It could be anything that's iterable. We'll give it a list, and so we'll say the first column is going to be the first column is going to be time. The second column we'll say is temperature. And we'll even say this is in, how about Fahrenheit? And then the third column we'll say is humidity, and this is going to be in percentage, in percent. So this is going to write out these three values with a comma in between them. And I'm going to write this as the very first row. And because I'm opening this file with the W option, it's going to blank out the file if it already existed. It's going to blow away any of your previous sensor values. So, I know that this is going to be the very first line, this header line. And now let's just jump into a loop forever. So we'll say, while true, and let's make up some sensor values here. So, let's how about we'll say my temperature equals random.uniform, and let's go from like -32 to 100. So this random.uniform, this will just pick a random floating point value between -32 and 100. So a real handy function to have. So this will give me some random kind of temperature value, although hopefully my temperature is not swinging that much every second, but hey, it's just some junk data. Humidity then, let's do equals random.uniform from 0 to 100. And then time. So I want to say, and we'll say time string, just because if I made a variable called time, that's going to confuse Python because there's a module I imported called time. And so you'll get really weird subtle errors. So let's just call this my time string value in here. Or how about this? How about time now, we'll say. And what I'm going to do for this is the date time module .datetime class .now. And so this is just another Python module. One thing I don't like about Python is the dates and times. It's a little messy. There are two different modules. There's the time module, which deals with the Unix style times of like, milliseconds since the epoch of like, January 1st, 1970. And then there's the datetime module, which deals more with a datetime object where you've got, explicit hours, minutes, seconds, and you can convert that into all kinds of different formats, and you can have time zones and all kinds of stuff associated with it. So, it's one little prickly part of Python. At least as a beginner, the date time stuff really confused me. But in a lot of cases, the datetime module is what you want to use because it has all kinds of classes for dealing with like different time zones and stuff. This now function just says give me the current system time basically, but as a nice datetime object. And the nice thing is when this datetime object is converted to a string, actually here I'll show you if we run the Python interpreter. So if I import datetime, if I do foo equals datetime.datetime.now, then if I look at the foo object, it's telling me this is a datetime object with the current date and time. But if I convert this to a string, then it gives me a nice little human readable string right here that says, okay, here's your year, here's your month, here's your day, here's the time and the milliseconds and things inside of here. And so this is the type of data that I want to put into my CSV file, as that first column, because it's kind of a standard format that a lot of things like spreadsheet programs can read, and they can kind of natively figure out that, oh, I see a string that looks like a date and time. So, if I build a chart, then maybe it'll show with date and time kind of values inside of there. So that's why I'm using this datetime object inside of here, because it's going to convert to a string and have a nice little human readable value. So okay, let's just print out the values that we generated. So we'll say, the time, and then the temperature, and then humidity, and then we'll use the format function, and we'll just give it all those values. Oh, I want to give it time, and then temp, and then humidity. So there we go, there's that. And then let's just call the write row function. So, and remember, we're in a loop here. So every time I call write row, it's going to add a new row to our sensor writer object. So we'll say sensor writer dot write row. And this is nice. Then I just pass it a list of my values that I want to write. So I'm going to say time now. We'll say temperature, and then humidity. And I do want to be careful that I get the order of these the same as the order of the header row that I wrote above, because the CSV format, like it doesn't know that this value is time and it's supposed to be associated with time. It actually can. If you read the documentation, they have this dictionary reader and dictionary writer where you can actually call write row and give it a dictionary object that says, here is my time now value and here is my temperature value, and it knows because you told it ahead of time. You've kind of configured it to say like, here's the different headers, the different columns that I have inside of here. So you could use that, but I'm just going to keep it simple here because I think just dealing with this as a simple list of values is fine for our program. So there's that, and then let's just sleep for a second. So we'll just wait for a second, basically. So we'll just generate random values. So let's run this. We'll do Python 3, we'll say O3 time series CSV. Oops, looks like I got something wrong here. So sensor write, I think that should be sensor writer. There we go. So we'll save that, and then let's run this. And so now you see every second it's just printing out, like here's the time, the current time, and then you can see random temperature values, and you're getting these big floating point values. But it's just showing like this is some random data, and same thing for humidity. So it's some random value between 0 and 100 here. So we'll let this run, and then I'm just going to press Control C, and so it's saved everything to a file. And so I should see that file if I look, LSL, and if I cat the sensor.csv file, then you can see here's the contents of this file, and it's a comma separated file. So there's, and you can see here's our header row, time, comma, temperature, comma, humidity, and then each row after that is just a different reading. And so you can see why I think this makes a lot of sense for time series data, where I've got all these sensor measurements and they've got a timestamp associated with them. So it's a very easy data format. Like I can look at this as a human and understand like, okay, so at this point in time, here's what my sensor reading was. And I might even know, like, this file, everything, the time is always increasing. So if I want to see the most recent value, I scroll down to the bottom and here is the last reading that we took for this. So it's easy for a human to read, easy for a machine to read. So, you've got the Python classes here. They have a CSV reader class where you can call, you can just iterate over the rows and it gives you back each of the different values that were separated by commas inside of there. So I could write a program to parse this. But I'll show you now, you can actually load this into a spreadsheet. So pretty much every spreadsheet program can load a CSV file. It's a very common format when you're dealing with data. Now I'm looking at Google Sheets or Google Docs. They have an online spreadsheet editor, so I'm just going to use this. But I'm sure you could use, like Excel if you have that program installed, or I think there's an online version of Excel you could use. You could use that. Apple has spreadsheets. Pretty much every spreadsheet that matters has a way to import CSV style data. Now in Google Sheets, I created a new spreadsheet, and you just go to this import command under File, and I'm going to choose to upload a file, and I'm going to pick, so this is connected to my Raspberry Pi right now, and here's that sensor.csv file. So I'm just going to tell it the sensor.csv. The cool thing is Google is actually, the Google Sheets program is really smart. It knows, okay, this is a comma separated file. It looks and sees that it looks like we're using commas to delineate this. Like it's going to automatically detect our separator. So I'm just going to say, like, let's replace the current sheet, and it's going to detect this automatically. I could explicitly say that I'm using commas, but it seems to be smart enough to figure it out. So we say import. And here's the cool thing. So it imported our data. You can see, like, there's our time row. Here's our humidity row inside of here. Oops, let me see if I can kind of move this thing out to the side. Oh, I guess my mouse, oh, there we go, yeah. So you can kind of see these, here's the data inside of here. So that's cool, and it has, exactly the same values that we read here. Now, the nice thing is, because this is a spreadsheet program, I can go in and say, let's turn this into a chart. So if I select all these columns and I say insert chart, then it's pretty smart, and it figures out and says, okay, this time column here is probably what I want the x-axis to be, and then these humidity and temperature are just different series of data inside of here, and it's actually just building a chart for me. So I'm just going to pick the defaults, and we'll just throw this chart in here. And look at that, it's super easy. Like these are fake sensor values, but if you had real sensor data, you could see a chart, and like maybe I'm looking at a week's worth of sensor data or something. You can see like how temperature and humidity changes over time inside of here. And so I like this kind of style of just saving your time series data as a CSV format. It's easy, you can understand it. Spreadsheet programs like this can understand it. They can build these nice little fancy charts. You'll get that stuff basically for free just because you've put your data into this comma separated format, and it can load it up, and you can go crazy with this. You can edit this chart. There are lots of different types of charts. Like, let's see, I think they've got, you can do like a bar chart for this, a histogram, all kinds of stuff. Like here's a bar chart, you can see like that. So that's pretty cool. And I think they even have a continuous kind of graph somewhere in here where it does like nice little curves in between here. So that, lots of different ways that you can tweak this. But that's what I wanted to show, is that, you might have data like this where you have time series data. You have a lot of sensor measurements, or, maybe different actions that happened, maybe a sensor that you're reading, and whenever it changes, you write some value to it. Like if you're detecting maybe like a security system you've built and you have all these sensors on your doors and windows and stuff, and maybe it writes an event every time a sensor gets tripped to the CSV file. So you've got all this data that has a timestamp associated with it. If you store it as a CSV file, it's easy to do it in Python. You just use this CSV class, write out your data, and then it's in a great format. You can load it up in a spreadsheet. You can go crazy with it. You can analyze the data and draw different conclusions for it. So I think that's it. So if folks have questions, throw them into the chat, and I'll see if I can get to them. Like I said, I wanted to just show a couple different ways to store data, like your program state, and then also time series data, like sensor data in this stream. And so like I showed with the program data, your state of your program, you can use the pickle module, great way to store Python objects, or you could use the config parser to use an INI style configuration file. And I talked about, what are some advantages and disadvantages. Like pickle is easy, but it's not easy for a human to read that format. Whereas config parser is also pretty easy to use, but the big advantage is that it's a text file and it's easy for a human to read that and edit it. great way to store your program state, I think, of like how this program should be configured. And then the last thing, like I just mentioned, is the CSV format where you've got some data, big set of data all associated with a point in time. Great format for that data there. So let's see, there was one question: what's the relative speed of the different persistent storage mechanisms in Python on the Raspberry Pi? Yeah, great question. So like I kind of mentioned, and I glossed over it with the pickle module, back in Python 2, there was a difference. So if I go to the Python 2 documentation, you'll actually see it mentions there's a cpickle module. And so the cpickle module, it serializes and deserializes using code that's written in the C programming language. It's basically a C extension. So it's a little bit faster. Like, it doesn't have all this overhead of creating Python objects and things internally. So that's going to be a little bit faster. They actually say up to 1,000 times faster. So yeah, that's more than a little bit faster. In Python 3, I believe, but I might be wrong, you probably want to read the docs to be totally sure, I think they switched to that cpickle style natively, so you don't need to worry about or care. I think they kept the old pickle module probably for compatibility, that maybe people had used it before and wanted to use it. But yeah, it's a good question. The pickle module is probably going to be the fastest just because it uses, it's implemented in C, and so it's going to be very quick to deal with. It's not going to have a lot of overhead of objects and things that it needs to create. Whereas config parser, I don't know for sure, but I have a feeling it's probably just implemented mostly as pure Python. So that's probably going to be a little bit slower. But the best thing is just try it out. It's not too hard to implement both of these kind of options for saving your data. And then Python has a really nice little function. I think it's called timeit. And the timeit module. This lets you run some code and see how long that it took to run. And so that's a great way if you want to just like test two different implementations. You can use timeit and say, okay, how quick was it to read my file one way versus the other way. I should preface it all though and say, like, in general, premature optimization is the root of all evil. So when you're first starting out with your program, don't worry at all about the performance, unless it's like, the whole point of your program is to be performant, like you're writing a game or something that runs in real time. But if you're writing something that's dealing with like sensor data and stuff like that, don't get caught up in like, oh man, I need to use cpickle and I need to optimize my code before I even, write any code. Go into this rat hole of how to make it fast. Get it working, get test cases and things you can use to validate your program so that everything's great. Then go in when you see a need to increase the performance. Like, maybe you're noticing that it's really slow for your program to start, and you use the timeit function and you see like, oh yeah, it's taken like 90 milliseconds to load this file or something, and that's way too long. Then go in and figure out, okay, maybe the INI file was too slow to load, and see if maybe I need to switch to something like pickle. So, I'd say don't worry about the performance, but when you do need to worry about it, yeah, check out the standard documentation in Python. It kind of mentions when there's a fast version or a slow version of things. So that's it. I think that's it as far as questions go. So thanks a lot for watching. I'll wrap this up. It's Tony from Adafruit doing this little stream on data storage. And like I said, I think this will just be a self-contained thing. I don't think I'm going to do a series on this yet, but I do want to do a future one on some basic database usage. So we might come back to how can you store and retrieve your program state from a database file, which if you've never used databases, it's pretty interesting. They can be a little scary, but they can also be super powerful and super easy to use with Python. So we'll look at that. But I like to stream a couple times a week. So I do a Monday stream, which I think I'm going to call Raspberry Pi Quick Looks, because basically I look at an interesting piece of software. So I just try something out. This week I looked at Chromium OS, the Chrome OS version. You can run on a Raspberry Pi. So next week, I'm not sure what I'm going to do yet, so we'll have to see. It'll be a surprise for Monday. And then Friday, I like to do more in-depth stream like this one. So I wrapped up last week. I did a whole series on Wi-Fi boards talking to Raspberry Pi. This week I did a little one on data storage. Now next week, I won't have a Friday video. I'll actually be out at Maker Faire, so we'll skip that one, but maybe I'll have some videos from there. And then I also won't have a Monday stream the week after next, but I definitely have one for this coming Monday, so we'll do that. But that's it. So subscribe to youtube.com/Adafruit. You can see this video and all kinds of other videos and projects. Twitch.tv/Adafruit. That's where I stream to, and where all kinds of other live streams occur. So we've always got lots of new stuff almost every day, new different live stream and video coming out. So check that out. Like, comment, subscribe. Let us know that this is useful stuff and that people like it, and we'll keep doing it. So thanks a lot. This is Tony from Adafruit, and I'll see you guys later.